Hello. In this tutorial we will create a VS plus parameterization of a simple system. To do this, we open the intersection version we copied earlier. The orange symbols show us which tiles we absolutely have to edit. These include the signal groups, conflicts, intergreen times, and signal programs. Before we get started, let's take a quick look at the topology editor. The operation of the editor is explained in a separate tutorial. Here we only use it to illustrate the system, which we then parameterize. It is an easy pedestrian crossing with two directions of travel, from west to east and from east to west, as well as a pedestrian crossing these lanes. The topology is also used to generate map files for CATS applications. However, that's not the subject of this tutorial and is not required for the definition of the base objects. Our focus is on the parameterization of the system. We now first enter the three required signal groups and click on the Add Signal Group button. We assign a name to the new signal group and select a sequence pattern. To do this, I can open the sequence pattern editor by double-clicking on the field marked in red. I choose a suitable sequence pattern here and go back with Save. I also mark the main direction checkbox to signal that it is a signal group in the main direction. As explained in the separate tutorial, I can also change sequence pattern afterwards. I now copy the first signal group and use it to create the signal group SG2 for the opposite direction. Finally, I also record a signal group for pedestrians with a suitable sequence pattern. If necessary, I can define the off behavior for the main direction. I select yellow blinking, save my changes, and go back to navigation. Now I enter the conflict matrix by opening the corresponding tile. I add a new matrix and define the conflicts by clicking on the matrix. Once I'm happy with my definition, I'll return with Save. I proceed similarly for the intergreen times. I open the editor and add a new matrix first. I now enter the intergreen times in the matrix. Later on, there will also be the possibility to calculate the intergreen times according to various standards here. For now, we'll be happy to manually enter values calculated elsewhere. We make a copy of the matrix for illustrative purposes and decrease two values in the copied intergreen time matrix. The validation immediately indicates that the values are not allowed. The first matrix we defined was automatically marked as a safety-relevant matrix. If these values are now undercut in another matrix, a validation points to this error. I now declare my second matrix with the lower values by a click on the checkbox to be my new safety-relevant matrix, save my customizations and go back. A signal program is still missing. I open the editor and add a new signal program using the Add Signal Program button. Using the three-dot menu at the beginning of each line, I can add up to 2 calls per signal group and position it in the cycle by dragging with the mouse. The cycle time was automatically set to 60 seconds here. For the signal groups SG1 and SG2 in the main direction, I give a bit more green time. By referencing the previously defined intergreen time matrix, the intergreen time conflicts are now indicated by colored bars. I now also move the pedestrian green at a suitable time. At the top of the signal program I discover another message. The definition of the switch-on time is still missing, which I choose in a range where there is no signal transition. I choose a value at about second 6 here. With this we can complete this editor and return. Now we would theoretically be done. In order to create a truly traffic-actuated VS Plus control, however, we also need to define registration means or detectors. I define detectors in the tile parallel inputs. I insert 3 detectors D1, D2, and PD3 and assign the corresponding signal groups to the detectors. After adding a detector and specifying a name, I can double-click on the signal group field, which opens a sub-editor where I can assign the appropriate signal group to the detector. In addition, I also assign a type to the detectors. In our case, this is individual transport and pedestrian. It is as simple as that. With this, we have defined the base objects. In the next video, we will show how this basic configuration can be used to create a traffic-actuated VS Plus control.